ME 8593 Design of Machine Elements Unit 3 Temporary and Permanent Joints Threaded Fasteners. Hello students, here in this video we will see the topics of tutorial problems in eccentrically loaded welded joints in Shear, presented by Department of Mechanical Engineering, Tandai Periyar Government Institute of Technology, Vellore. Problem 3. The structural connection shown in the figure, this is the structural connection, is subjected to an eccentric force P of 10 kN with an eccentricity of 500 mm from the CG of the bolt. 500 mm from the CG of the bolt. This is the center of gravity of this arrangement. Okay, this eccentrically loaded 500 mm. That means E, small e value is 500 mm. The center distance between bolt 1 and 2 is 200 mm. The center distance between the bolt 1 and 2 is 200 mm. And the center distance between the bolt 1 and 3 is 150 mm. Center distance between the bolt 1 and 3 is 150 mm. All the bolts are identical. The bolts are made from plain carbon steel 30C8. Yield strength of this bolt is 400 Newton per millimeter squared, and the factor of safety is 2.5. Determine the size of the bolt. Determine the size of the bolt. 1, 2, 3, 4. Okay. Find the suitable size of the bolt which we are support this eccentric load, 10 kN of load. Okay. Let's see. Given data, P is the 10 kN load, eccentric load, and E is the 500 mm. That is the distance between center of gravity to load acting on this point. And then distance between bolt, center distance between bolt 1 and 2 is 200 mm and 1 and 3 is 150 mm, and the yield strength is 400 Newton per millimeter square, and factor of safety is 2.5. Okay. Solution. First of all, step 1. In step 1, you can find the permissible shear stress. Okay. The formula of permissible shear stress is tau equal to shear strength divided by factor of safety. Here we don't know shear strength value, but shear strength equal to 0.5 yield strength. Okay, this is the formula we can apply here. 0.5 SYT divided by factor of safety. We know the SYT value. That means yield strength value is 400 Newton per millimeter square. Apply here, and we can get the 80 Newton per millimeter square. Permissible shear stress is 80 Newton per millimeter square. And step 2, can find the primary and secondary shear forces. Okay. By symmetry, in center of gravity, G is located at the distance of 100 mm to the right of the bolt 1 and 2, and 75 mm below the bolt 1 and 3. That means the center of gravity to the center point. This line is called a radius of the arrangement. This is the center of gravity. The center point to this center line is called a radius 1, R1. The center point to this center line is called a R2. This is R4. This is R3. So here R1, R2, R3 and R4 both are same distance only. So R1 equal to R2 equal to R3 equal to R4 equal to R. Here we can find the R value using the Pythagoras theorem. Here take this triangle. This is the triangle. Okay. In triangle, what is the Pythagoras theorem? This, this is the AB squared. Sorry, AB, AB and C. Okay. So this value is radius. R squared equal to R equal to square root of this value plus this value. Okay. This value is 100 millimeter. This value is 75 millimeter. Okay. Already they are given. Okay. Now R equal to square root of 100 squared plus 75 squared. Now we can get the radius of this value 125 millimeter. Okay. The next, this is the vector addition of shear force diagram. Here this is the center of gravity CG point. Here too, this point is bold 1. This 1 and 2 is the bold 1 and 2. Okay. Correspondingly bold 1 and 2. Here 1 to this distance is 75. CG to the bold linear distance is horizontal distance is 100 millimeter and vertical distance is 75 millimeter. Here this line is the R1. Okay. The secondary shear force is acting on perpendicular to the radius of this line. This is acting on perpendicular to radius line. This is the radius line. So the shear force is acting on perpendicular to the radius line. Okay. The primary and secondary shear force are shown in figure. This is the primary. P dash 1 is the primary shear force. P double dash 1 equal to 1 is the secondary shear force. Here P dash 2 is the primary shear force at bolt 2. P double dash 2 is the secondary shear force at the bolt 2. Okay. Now primary shear force all are equal. P1 dash equal to P2 dash equal to P3 dash equal to P4 dash. Here the load is 10 kilonewton. 10 kilonewton means 10 into 10 to power 3 Newton. That means 10,000 Newton divided by 4. Because number of bolt is 4 bolt. So we can get the load is acting equally in 4 bolts. Okay, 200, 500 Newton. Then secondary shear force at bolt 1. Okay. Now P into E. Take the moment about E into radius of bolt 1. Okay, R1. Okay. PE into R1 divided by R1 squared plus R2 squared plus R3 squared and R4 squared. Okay. This is the formula. Now here R1, R2, R3, R4 are equal distance. So you can take it as a R. Here R1, R2, R3 are taken as a R. So 4 R squared. Here 1 R. Here 1 R. This will be cancelled. So we can get PE divided by 4R. Okay. Then we can apply the value of loads. P equal to 10 kilonewton into E equal to this E distance is 500 millimeter divided by 4 into R value is you can find here 125 millimeter. Okay, you can apply this value in this formula. We can get the secondary shear force. Okay, this is the secondary shear force. Similarly, it can be proved that P P1 double dash equal to P2 double dash equal to P3 double dash equal to P4 double dash equal to 10,000 Newton. Okay. Now step 3. Resultant shear force. Okay, we can find the resultant shear force referring the figure. Okay. Here tan theta equal to 0.75 divided by 100. Here this is the theta value. We can find the what is tan theta equal to opposite side by hypotenuse. Okay, this is the theta, this is the opposite side, this is the adjacent side. Sorry, tan theta equal to opposite side divided by adjacent side. Okay, this is the opposite, this is the adjacent. This opposite side is values 75, adjacent side values 100. So we can get 0.75 and resolve this equation. Now we get the theta value is 36.87 degree. Okay. Now we found the load at bolt 1. P1 equal to square root of P1 double dash cos theta minus P1 dash whole square plus P1 double dash sin theta whole square. Okay. Now we can know all the value here. Secondary shear force value we know, and theta value we know, and primary shear force value we know, and theta value we know. Apply all those values here, we can get the shear force at the bolt 1 P1, then P2. Okay. Similarly, we can apply the value to this formula. We can get the value. This is the value is 12,093. This is the value is 8,193. As we know, bolt 2 and 4 are subjected to the maximum shear stress. The bolt 1 is compared with bolt 2 is minimum. The bolt 2 is subjected to the maximum shear stress. In simple concept, which the bolt is near to the acting on the load, that will get the maximum shear force. Here the load is acting here, the nearer bolt is 2 and 4. This farthest bolt is 1 and 3. So 2 and 4 is get the more shear stress generally as compared to the bolt 1 and 3. Okay, this is the simple concept. Which the bolt is nearer to the acting on the load is get the more shear stress. Okay, that will be found here. Okay, so bolt 2 and 4 are subjected to the maximum shear force here. Next, we can find the size of the bolt. Size of the bolt, shear stress equal to load by area. Okay. Okay. Generally, we go with maximum load. Okay. Here the bolt 2 and 4 are the subject to the maximum shear stress. So we go with the bolt 2. Shear stress equal to P2 divided by area. Okay. You know the shear stress already we found. Here is the permissible shear stress, and the load, sorry, shear force acting on the bolt 2 is 12,093.38 divided by pi by 4 dc square. This is the core diameter of the bolt. Okay, because load is acting on core diameter of the bolt only. Okay, using this equation we can find the dc value 13.87. As using this equation dc equal to 0.8 d. With this equation we can find the value of capital D, nominal diameter 17.38. Okay, say 18 millimeter. Okay, you can found 13.87 means, let's see, 13.87, where is the minor diameter? 13.87, 13.546. So we can go the next value, 16.933. So we can find the value of standard bolt size is M20. Okay, the standard size of the bolt is M20. You can see the PST decision data book page number 5.42. Okay. Okay. You can see the next problem. Problem 4. A steel plate subjected to a force of 5 kilonewton and fixed to the channel by means of 3 identical bolts as shown in figure. This is the 3 identical bolts 1 and 2. This is fixed by the load of 5 kilonewton. Okay. The bolts are made from the plain carbon steel 48C8. The yield strength is 380 Newton per millimeter square, and the factor of safety is 3. Specify the size of the bolt. Okay. With this condition, we have to find the suitable size of the bolt. We have to use the in this structure. Okay. Okay. Given data, P equal to 5 kilonewton and yield strength equal to 380 Newton per millimeter square and factor of safety equal to 3. Okay, step 1. Find the permissible shear stress. Permissible shear stress equal to tau equal to shear strength divided by factor of safety. Here shear strength equal to 0.5 yield strength. Okay, then apply this equation and we can find the tau value. Permissible shear stress value 63.33 Newton per millimeter square. And step 2. Primary and secondary shear forces. The center of gravity of 3 bolts will be at the center of bolt 2. Okay, let's see, this is the center of the bolt, this is the CG of the arrangement. Okay, this arrangement, the bolt 2, this position is the center of gravity of this structure. Okay, in this 3 bolt, this is the center of gravity. Okay, bolt 2 is. Then the primary and secondary shear force are shown in figure. Okay, this is the primary shear force. P1 dash, P2 dash and P3 dash are acting on perpendicular. Okay, here also the load is acting, secondary shear force is acting on perpendicular, P1 dash, P3 double dash. Okay, here we can get the moment. Okay, due to the load, this bolt we get the moment only. Here also force and reaction are same here. Okay, now you can go P1 dash primary shear force, P1 dash equal to P2 dash and P3 dash, both are same, so P divided by 3. Okay, the load is 5000 kilonewton divided by 3, so you can get the value of P1 double dash primary shear force equal to 16,066.67 Newton, and we can find the secondary shear force P1 double dash and equal to P3 double dash. Here at the bolt 2 you can get the only moment only, P1 and P2 you can get the shear forces. Okay, so P1 double dash and P3 double dash are here, PE into value is P load into this value, center of gravity value, into radius of this is the radius from 1 and 2 bolt. Okay, R1 divided by, sorry, divided by R1 squared plus R3 square. Here R1 and R3 are same. Here R1 and R3 are same because the distance is 75 and 75 only. Okay. P equal to P value already we know 5000 into E value is, what is the E value here? 200 plus 30, 230 plus 75. This is the center of gravity, CG point. So 200 plus 30, 230, 230 plus 75, 305. The center of gravity point is 305 millimeter. Okay, you can apply here 305 into R1 value is 75 into 75 square plus 75 square. Okay, R1 value and R3 value are 75 respectively. Okay, apply this value to in this equation, you can find the secondary shear force. Okay, okay, and step 3, resultant shear force. The resultant shear force on the bolt 3 is maximum because the load is acting nearer to the bolt 3. So maximum shear force acting on this bolt only. Okay, already I told in previous problem which the bolt is nearer to the acting on the load, that bolt is acting subjected to a maximum shear force. So the bolt 3 is subjected to a maximum shear force. So P3 equal to primary shear force plus primary shear force at bolt 3 plus secondary shear force at bolt 3. So adding this value, we can get the maximum shear stress shear force at the bolt 3, 11,833.34 Newton. Okay, now we can find the size of the bolt in step 4. Shear stress equal to load by area. Load at bolt 3 divided by area. Area of the core diameter here. Okay, we can found already we can found the permissible shear stress and we know the resultant shear force of bolt 3 and area. Area equal to pi by 4 d square, sorry dc squared. From this equation we can find the dc value, core diameter. From this core diameter we can find the standard diameter of the bolt, outer diameter, or else using this equation we can find the outer diameter. dc equal to 0.8 d. From this we can find the 9.28. Using this value, minimum diameter, we can, let's see the data book. DC equal to 15.42 minimum diameter. Let's see minimum diameter minor diameter 15.42. This is the value 16.933. Correspondingly, we can get standard bolt size is M20. Okay, the standard size of the bolt is M20. Okay, the M20 bolt is suitable for this arrangement. That bolt is used to carry the this 500 kilonewton load. Okay, thank you.